Subgroup meta-analysis for a binary outcome in SPSS to generate forest plot and funnel plot. Binary outcome is an outcome or a variable that have two levels in it: a variable that is categorical, that is binomial, that has either yes or no categories or level, or accept or doesn't accept, agree or doesn't agree, dead or alive, have cancer, doesn't have cancer, smoke, doesn't smoke. So this is a binary variable that is binomial and can only have two levels in it. Meta-analysis is a statistical method that is performed to combine results from several independent research studies, aiming to provide a pooled or overall estimate of the effect size for specific intervention or treatment compared to control. For studies that investigate the same specific scientific or medical research question. Meta-analysis will also measure the variability among studies by performing a heterogeneity test. A heterogeneity test will assess and examine the degree of variability or inconsistency in the result from these several multiple independent studies. And also the heterogeneity test will generate an I-squared value, which is expressed in a percentage, with a 0% indicate no heterogeneity, which means homogeneity in the result, and 100% indicates maximum heterogeneity. Meta-analysis also will generate a forest plot. So what is a forest plot? A forest plot is a graph that displays the summary of the result from the meta-analysis. It summarizes the effect size measured, whether it is in this case a binary outcome or any other outcome, and also it produces the estimate overall effect size and the estimate effect size for each specific studies with 95% confidence interval. The forest plot consists of three parts. The first part is statistical description of each specific study with estimate of effect size, p-value, 95% confidence interval, and weighted percentage. A second part, which is a diagrammatic reflection or representation of the descriptive study, and a third part, which generate an overall estimate of the effect size with the p-value and also results of heterogeneity test. The other plot that can be produced from meta-analysis is the funnel plot. Funnel plot is a graph that displays in the x-axis the estimate of effect size for each individual research study, and on the y-axis is the standard error or the sample size. The objective of the drawing funnel plot is to examine publication bias. The estimate effect size in this video will be the odds ratio. Here in SPSS data view, I had inserted data from 12 independent research studies that addresses the same scientific research question. So the studies are labeled from 1 to 12 on the column or the variable labeled as study ID. The other variables or columns are the one for the treatment, T for treatment, and C for control. Each study has designed the research to recruit participants into the study and arrange them into either a treatment or intervention or exposure group and a control group or a reference group. Here in this case, the treatment group are given a drug to test the efficacy of the drug in treating the condition, and the control are given a placebo, and the number of participants who completely recovered from the condition are counted and scored and inserted in this section. The first column here with the data is the treatment event or success. The next one is the treatment no event or failure, and the third one is the total participant in the study, those who had succeeded and those who had failed to recover from the condition. And the control also, there is a count for the event occurrence, which is the success without or the recovery from the condition without intervention, and also the failure to recover without intervention, and the total of participants in the control group. And in the far end section here is a variable for gender, in which the first 6 studies they were looking at only male participant, and in the next half or the remaining 6 studies, other studies, they were recruiting only females. Since the outcome here for each study is a binary or binomial, either there is a success or failure, event occurring or event not occurring, so it is a binary outcome for the treatment and for the intervention, then the effect size that will be estimated here will be the odds ratio. Meta-analysis can be performed to combine all this data from all the 12 studies and find out the overall pooled effect size and determine the level of or the percentage of heterogeneity among the studies. So either a meta-analysis can be done for all the 12 studies, or a subgroup meta-analysis can be performed, and the subgroup will be based on the gender for male or females. And the way to do the subgroup meta-analysis in SPSS, click on the analyze section here, then choose the meta-analysis option here, and since the outcome is binary, select the binary outcome and then click on the raw data, as we have here raw data. Here in this new section, our window for meta-analysis, binary outcome, a section for variable or variables, and a section for treatment group and control group, and a section for effect size, whether for odds ratio or risk ratio, and a section for model. So for the treatment group, move the treatment success into the section here, and the treatment failure into this part. And for the control group, move the control success into this part here, and for the control failure into this part. And for the study ID, select the study ID and move it to the section here. So here we have 2 groups, treatment and control, and the event happening in the treatment is selected for the variable for that one and for no event, and similarly for the control group. The effect size to choose from here will stick with the log odds ratio, and for the model we'll use the random effects model. On the selection here, click on criteria and there will be no selection. On the analyze or analysis, here is the section where we will perform subgroup meta-analysis, and since the variable that we will use, or we will subgroup the study based on the gender, then move the gender into the section here for subgroup analysis. Click on continue, and for inferences no changes will be performed. For bias I will tick on the Eagers test and then click on continue. For time and fill, no selections. For print, here it's very important to generate values for the I-squared and heterogeneity test. So tick on the test of homogeneity, tick on the heterogeneity measure. For the effect size for individual study, tick on that, and tick on the prediction interval under random effect model, and tick on display exponential statistic. Click on continue, and for save no changes. And for plot, here an important part for to generate several plot will stick with the forest plot and the funnel plot. So to produce a forest plot, tick on the square here, then select and tick the effect size, the standard error, the confidence interval, the p-value, and the weight. Here under this section, also for annotation, select the homogeneity, heterogeneity, and test. And for reference line, select the overall effect size and the null effect size. And for the funnel plot, tick on the selection option here for funnel plot and move the study ID to the label, and then click on continue. Now if we click on OK, an output will be generated in SPSS, and as shown here, a meta-analysis summary is given, showing that the outcome is binary, the effect size measure is the odds ratio, the model chosen is random effects, and the weighted or the weight is inverse variance, and the estimated or estimation method is given here. Scrolling down into the section for the test of homogeneity, as shown here, shows the test of homogeneity is based on the chi-square Q statistics, and a value is generated for the male and for the female group, and the significant value is given here. And as shown here, that the p-value is greater than 0.05. So for low level of heterogeneity, we need this to be higher than 0.05. So here from this data, it is confirmed that there is less degree of heterogeneity, and can be confirmed by the I-squared, as shown here, that the I-squared for the male is 0% and for the females is 37.6. Here the 37.6 is there shows that there are a certain level of heterogeneity among the studies for females, and also as shown here, an overall I-squared for the gender is also given here, which is 12.2%, which is a low level of heterogeneity, and also a test of subgroup homogeneity for the gender is given here, and it shows that that is higher than 0.05. So from these three sections or three tables, we can say that males have no heterogeneity. The studies that only contains male have no heterogeneity. So all the results are homogeneous. For female or females study, there is a heterogeneity, and overall there is low level of heterogeneity for both gender. We'll leave this Eagers regression test later on, as this is to check for bias of publication, which is another confirmation for the funnel plot. Scrolling down to the forest plot diagram or chart, as shown here, this plot consists of three sections. The first section here is a descriptive section, statistical description, a diagrammatic representation, and a third one, which is the overall estimate effect size and the test of heterogeneity. In the first section here, each study is given and the meta-analysis is performed based in subgrouping: gender for male, the first 6 studies for male, the next 6 studies for females, and the ID for each one of them, with the subgroup overall values are given for both sections, the male and the females. So in the first section here is the odds ratio for each individual study is scored and recorded here, and the standard error is given with the 95% confidence interval for the lower limits and the upper limit, and the p-value for each individual separate studies, and the weight percent is also given here, and the weight percent reflect the effect of the sample size on the overall meta-analysis calculations. As shown here in the lower part is the overall estimate effect size, which is the overall odd ratio given here with the 95% confidence interval, standard error, and a p-value. Looking at the next section here, which is the diagrammatic representation of the descriptive values. As shown here, the red line is the overall estimate effect size, which is the odd ratio, which is 2.7. As shown here, the overall odd ratio is 2.79, and the ruler at the bottom here is a scale from 1 to up to infinite, and that's for the odds ratio. The squares here represent the odds ratio for each individual studies, as colored here or color coded with blue, and as shown here, there are squares that are small and large. So large square reflect higher weights, higher sample size. Smaller one reflect smaller sample size studies. And as shown here, the odd ratio for each individual study is plotted, and the diamond shaped symbol here represent the overall odds ratio for each group, for the male group and for the female group. So here we have blue squares for effect size for each individual study, a green diamond for the overall odds ratio for the male and the odd ratio for the females, and also a third diamond, which is the overall odds ratio for both combined male and females without subgrouping. And as shown here, that the OR odd ratio over all odd ratio for males is 2.96, and for females 2.71, and the overall odd ratio is 2.79. The horizontal line here represent the 95% confidence interval for each individual studies and for the overall effect size that has been generated. To do few editing on the plot here, click on this graph or plot, and then double click on the 95% confidence interval and select that as shown here, and then let's make this 0.5 to make it thinner, apply, and as shown here, this made the horizontal line thinner. We could also change the color of the blue squares and even change the type if you wish. We could go for circle and we apply it, or we could go for any shape we would, but we'll stick with the square one and a blue one. And we could change the color into red and apply that, and also change the fill into red also, and then click on apply, and that will change the color into red. So several things can be changed here as it's needed, and if we just minimize that or get out of it to back again to the out of the editing mode, as shown here, there are 3 parts, and the third section here shows that the model is a random effect model, and the heterogeneity test based on tau squared and on the Q value for homogeneity or heterogeneity, and also a test for overall effect size with a p-value given here, which is significant, less than 0.05, and tests between subgroup homogeneity with a p-value given, and as shown here, the I squared is given to be 0.12, and the p-value is greater than 0.05. So from this graph, it can be said that there is a difference in the odds ratio between male and females, and the drug is or the treatment with the drug have a higher success rate compared to the control. Moving to the next plot, which is the funnel plot. As shown here in this funnel plot, there are 12 studies numbered from 1 to 12. On the x-axis is the odds ratio, and on the y-axis is the standard error, and the plot is in a shape of a funnel, and the line in the middle is the odd ratio or the pooled odd ratio or the overall odd ratio, which is 2.79. Objective of this plot to show whether there is a publication bias, and for the lack of publication bias, the distribution of the effect size or the odds ratio for the study should be equally on both sides of the line, or above the overall odds ratio and below it. And here there is bias of publication, as there are more odds ratio in above the overall odds ratio than below it, as here we have 1, 2, 3, 4, 5, 6, 7 studies, and here 1, 2, 3, 4, 5. So 7 on the right side and 5 on the left. So there is bias in publication as shown by this funnel plot. If we scroll down here, we can see that 2 funnel plots are produced, one for the male and one for the females. And as we can see here, the distribution for the males shows that there are higher proportion of the studies to the right. So there is asymmetry of distribution of the odds ratio, and for the females there are 3 here and 3 here, so studies are equally distributed on both sides. To confirm this observation, then Eager's regression test is done to test whether there is a bias. Looking at the section for Eagle's regression based test, which shows the determine or assess the publication bias for the group male and the group females and the overall group. And as shown here, looking at the p-value is less than 0.05. So we need the p-value here to be greater than 0.05. So the males, there is publication bias for the males or male study, and for females there is no publication bias as it is above 0.05, and for the overall there is a publication bias as the p-value is less than 0.05. So for publication bias, two way of testing that, through funnel plot and through Eagle's regression test. So this is the way to perform subgroup meta-analysis in SPSS for a binary outcome based on the effect size, which is the odd ratio.